Good morning. Today we start a new chapter, Equation of a Circle. This is the math department at Amjad School for grade 11. First, when you see the icon, stop the video and try to answer the question. So it's very important throughout this presentation, whenever I ask you a question and you see this icon, you stop the presentation, try to solve the problem and do it using a pen and a paper aside, then compare your answer to the given one in this presentation. Throughout this chapter, the plane is referred to an orthonormal system, X or Y. So whenever we consider certain point or points, or whenever we consider a straight line, assume that the plane is an orthonormal system. Let me start with a brainstorming about the equation of a line. What is the form of the equation of a non-vertical straight line? Concerning the equation of a line, the reduced form of the equation of a line is y equals ax plus b, as you know, where a is the slope of the straight line and where b is the y-intercept of the line. The equation of the straight line is extremely useful. You can use it to draw the line, to tell the slope of the line, to pick points on the line, to tell whether a point is on the line or not by plugging in the coordinates of this point in the equation of the line. We will also need in this chapter to know the distance between two given points. You have studied this in the fourth intermediate and also in the first secondary. How to calculate the distance AB if the 2 points A and B have coordinates A, XA, YA, and B, XB, YB. The distance between 2 points is given by the formula. AB equals radical difference of the X coordinates squared plus the difference of the Y coordinates squared. Example 1, given A 2 minus 3 and B minus 1, 2, calculate the distance AB. The solution of example 1. If A and B have the following coordinates, then the distance AB it's exactly the formula mentioned in the previous page, and you just plug in x of B minus 1 minus x of A 2 all squared. So you will get radical 9 plus 25, which is radical 34. So the distance between A and B, the distance AB, is radical 34. Now let's move to the new equation, which we are studying today about the circle. But first, let me ask, what are the basic elements that define a circle? You know the circle, you studied this in geometry, but you have never studied the equation of the circle as you did with the line. To draw a circle, you need the coordinates of its center and the value of its radius. Let's now try this GeoGebra activity. Assume that in the coordinate plane, you have a certain point I. The coordinates of I here are clear, -2 and 1. So I is a given point. This point is called the center of the circle. Assume now that you are given also a given value, a given distance, which is the radius of the circle. In such a way now we can draw this circle because we know where its center is and what its radius is. We may ask you to have or to get the equation of the circle given its diameter. If you have the diameter, it's very easy to find the center and the radius of the circle. So in general, if you want to deal with a circle in the coordinate plane, you must know the coordinates of its center and the value of its radius. So even if you are given the extremities of a certain diameter, then you will get its center by getting the midpoint of that and by getting the radius, which is the distance of the diameter over 2. How can we tell if a certain point A is on the circle? So let's say C is a circle with center I and radius R. How to prove that a given point A belongs to the circle C? To prove that a point A belongs to a circle C, you have to prove that the distance from the center to this point A is nothing but the radius R. Example 2, let C be a given circle with center I 1 minus 2 and radius 5. Prove that A belongs to C. The solution of example 2, C is the circle with center I, as we said, 1 minus 2 and radius R, and A has coordinates minus 2, 2. So we calculate the distance from A to the center of the circle, AI, using the distance formula. It's radical 1 plus 2 all squared plus minus 2 all squared, which is radical 9 plus 16, which is radical 25, which is 5, which is equal to the radius. Consequently, A belongs to C. So in general, how do we find the equation of the circle? For example, let's see be the circle with center I, 1 minus 2, and radius 3. In general, to find the equation of any geometric figure, it's enough to consider a general point, M, X, Y, on that figure and try to find a general relation. Let me use this GeoGebra activity. M is a point on the circle. M is a variable point whose coordinates are in general x, y. And C is a circle, as you can see, with center I 1 minus 2 and with a given radius 3. So again, C is the circle, center I, radius 3. MXY is a general point on the circle. And I want you to find a relation between X and Y so that M is on the circle. Solution to that, as we mentioned, we need to write a condition which is always true. As M varies on the circle, the distance MI remains constant, equals to the radius 3. So if IM is a 3, then we can say that IM squared is 9. This will lead to the relation, as you will see in the next page. So M belongs to the circle, then IM squared is 9. But what is IM squared? X minus 1 all squared plus y plus 2 squared. This is the distance formula, but without the radical, since we are squaring IM, and that's equal to 9. So in general, this is called the equation of the circle C. So it's a general relation between X and Y. So if you want to tell if any point is on the circle, on this circle or not, it's enough to plug in the coordinates of this point in this equation. You replace X by X of that point, and you replace Y by the Y coordinate of that point. If the equation is satisfied, then the point is on the circle. So in general, the equation of the circle of center I, AB in general, and radius R is X minus A squared plus Y minus B squared equals R squared. So this is the form of the equation of the circle. So in general, the equation of a non-vertical line, as we said, is Y equals AX plus B. So what is the equation of the circle in general? If you have its center I, AB, and radius R, it's X minus A squared plus Y minus B squared equals R squared. Example, find the equation of the circle of center I minus 2, 3, and radius 2. The solution to this example, equation of the circle of center I minus 2, 3 and radius 2 is x plus 2 squared plus y minus 3 squared equals 4. In this equation, we have replaced a in the previous page by minus 2, and we replaced b by 3, and we replaced r by 2. Let's check this GeoGebra activity again. As you can see in the figure, we have drawn a circle with center 1, 3 and radius 2. Consequently, the equation is x minus 1 squared plus y minus 3 squared equals 2 squared, which is 4. Let me change now the coordinates. For example, let me put here 0. Let me put here, for example, minus 1. So the circle now has the center I 0 minus 1 and its radius is 2. And as you can see, the equation now is x squared, no need to say minus 0, it's x squared plus y plus 1 all squared equals 4. Another example, if we put y also 0 and we change the radius to 3, then the circle will have the equation x squared plus y squared equals 9. So that's the equation of this particular circle that you can see here in the coordinate plane, whose center is 0, 0, and whose radius is 3. Example 4. Find the equation of circle of diameter AB so that A is 3 minus 4 and B is 1 minus 2. For sure, to find the equation of the circle, as we mentioned before, you need to know the coordinates of the center and you need to know the value of the radius. Since A and B are the extremities of a diameter, can't we get the coordinates of the center? And can't we get the value of the radius? Circle with diameter AB, these are the coordinates of A and B. So the center of the circle is I, which is the midpoint of A and B. So x of I is x of A plus x of B over 2, and y of I is y of A plus y of B over 2. So I, the center, has coordinates 2 minus 3. And the radius of this circle is, it's nothing but AB, the diameter, over 2. And to find AB, we apply again the distance formula between the 2 points, plugging in the values of the coordinates of A and B. As you can see, R is radical 1 minus 3 squared plus minus 2 plus 4 all squared over 2, and that's radical 2. So now we have the coordinates of I and we have the value of the radius. Consequently, we can write the equation of the circle. So it's x minus 2 squared plus y plus 3 squared equals 2. Can we find the equation of the circle using another method? Assume that A is 3 minus 4 and B is 1 minus 2. So can we write the equation of the circle without getting the coordinates of the center and without getting the actual value of the radius? We consider M, x, y, as we said before, a general point on the circle, and we know that this point belongs to the circle. To find the equation of the circle C, it's enough to find a general relation between x and y. But how can we find such a relation? Let me check this GeoGebra activity again. So we know the coordinates of A and B, which are the extremities of a diameter. M is moving on this circle. M has coordinates x and y. What relation exists for all points M on the circle? Can't you notice that the angle remains 90? What about the scalar product MA and dot and MB? The scalar product MA dot MB, as you still remember, if two vectors are orthogonal, perpendicular, then the scalar product must be 0. Writing this will lead to a relation. So first, we write the condition AM dot BM equals 0. We find the coordinates of AM vector, x of m minus x of a, y of m minus y of a. We find the coordinates of BM, and these coordinates are x minus 1, y plus 2. Therefore, we apply the scalar product x prime plus y prime equals to 0, and we get this relation. Do we consider this relation as the equation of the circle? The answer is yes. This equation doesn't have exactly the same form as the previous one, yet it's considered the equation of the circle because it represents a general relation between the coordinates of the point M. So you have the right to give your answer to the equation of a circle in this form. And we use this, or we may use this, whenever we are given the coordinates of the extremities of a diameter. Finally, I'm going to assign a homework for this part. Please, from your book, page 52, you do number 2, parts 1 and 3, number 3, parts 1 and 3, number 4, parts 1 and 3, number 5, then you do number 7, part 1. Thank you.